circle and its relationship to the sine and cosine, and we know that the x-coordinate of the point A on the unit circle here is the cosine of the angle, and the y-coordinate is the sine. So let's just look at the x-coordinate. So what we're going to do is, like, as A goes around like this, we can see the angle changes as it goes from 0 to 2 pi. That angle that forms from the standard location to the line PA. Okay, so like that would be the angle. So what we're going to do is we're going to unwrap the angle and put it along the x-axis. Alright? And so as we move the angle around, it's going to move out like this as we go around back and forth. Then what we're going to do is, for our y-coordinate, we're just going to put the cosine of the angle. So in other words, when it's in this location, the cosine of the angle 0 is 1. So 0, 1 would be the point there. Now as we move along, we can see that the angle is going to go down to 0, and then it's going to keep going like that. So it's going to move around just like the x-coordinate does here. It never gets bigger than 1, never gets smaller than -1. So if I stick on just kind of a few points around, just to kind of get a sense of what's happening, you can see that the curve that this is following is looking something like this. So we're moving something nice and smoothly through it. So it does follow the curve that looks like this. This is our cosine curve. You can see that at certain points, like pi over 2, it's 0, pi over 3, it's 0, at 0 it's 1, and at pi over 2, where it comes back to what it was, it's 1. Now, you'll notice that this thing repeats, so we could go the other direction, and we could go forward, because it's still just wrapping around the circle, so we're just getting the same motion, which is called periodic. So that periodic is when you get the same point over and over, and other points in between aren't equal to, I mean, you could have equal to, but it's actually all the points around it as well. So just like our two little black curves there, everything around it has to match up like that. And so we're getting the cosine curve. We're going to let the point unwrap the angle as the point A goes around, but this time we're going to graph the y-coordinate with respect to the angle. So as we go around like that, let's stick in C, and the angle, notice that at this time when the sine angle 0, the sine is 0, so they're in the same location. But this time it's gonna, the y value, because we're going up, gets bigger, goes up to 1 at pi over 2, comes back down to 0, and then keeps going up like that. So we get something that looks like that as we go around. So if I throw on my little curves like this, so I can kind of see what's happening a little bit before, I can see that it's moving like this as it moves through the graph. So again, it's just weaving up and down, and again it does it over and over. So if I throw in the sine curve here, we can see that we're moving along a curve that looks like that. The cosine function, but with the transformation stuff that we were doing before. So if you remember from before when we did transformations, if you change the C, that's going to move it up and down. If you change the A, that's going to stretch it or squeeze it. Now, there's something important going on here, and that's something called the center line. And so we have this spot right here. And if you look to the largest that the cosine gets, or the sine, and the smallest, that distance from the center line is called the amplitude. Alright, so now when we move the, if we change the amplitude, that would be the A. That's why I use the letter A. So if we get it bigger, you can see it stretches. The center line right now is staying at C, and it stretches the graph. If I make it smaller than 1, it squeezes it. If I flip to a negative, it just flips it over, just and then stretches it. So just like we had before, right? It stretches or squeezes the and changes the period. Now if I change the amplitude to say 2, you'll see the distance from the center line to either the max or the min, that distance is 2. So that A actually determines the amplitude of your sine curve. Now, the thing that doesn't change it is if I move C. Remember, C just adds up, moves it up and down. So notice the center line changes. It doesn't change the amplitude, but it does change the location of that center line. So again, if I moved it up, you can still see that the amplitude changes, and you can figure it out even if you don't know all the stuff like I've put here. You can see that the max is like 2.5 down to 1/2. You can add them together, divide by 2, it'll find the center line. If you subtract them, that would be the distance. So then if you divide it by 2, take the absolute value, that'll give you the amplitude. That'll give you the A. Now, if we go back, let's put this back to 0. Let's put this one back to 1. Take this back to 1, if I can get it in there. Okay, so now, what does the other two do? So on the inside, if you remember, it changes the graph. So if I change this one, if I make it bigger than 1, it's going to squeeze it. So notice that what happens is that you get more periods in the same amount of space. So it changes the number of periods. If I make it less than 1, of course it's going to stretch it out, and if I go negative, it's going to flip it over. But since the cosine is an even function, you don't see much change at this point, right? And so we get it squeezing in and out like that. Now if I take the D is called the phase shift. So if you have your cosine function or the sine function, you'll see written like this. You can see how this just moves it right and left like that. Now let's do something kind of interesting. If I graph the sine function, which is this, notice that all I have to do is shift it, and I have the cosine function is equal to the sine function. So in some ways the cofunctions of the other ones are the same thing. You just need to shift it a certain distance and you're right on top of the other one, and you have exactly the same curve. The sine function, it has the same properties as the cosine. There's the center line, the amplitude. If you stretch the amplitude by making it bigger than 1, you can just move it up and down. You can move it back and forth, squeeze it in and out, just like it was before. So if we put it at 1, and we put it at 1, you get this. Again, up and down doesn't change the period, changes where the center line is, and you can do the same thing. Transform it back and forth. And of course, if I have the cosine curve, again, I can shift it to be right on top of the cosine's curve. So you can move them right on top. So essentially they are the same curve, just a matter of a little adjustment.